All right, so let's start that. So today we're going to learn how to count the figures. Okay, could be squares, rectangles, or anyway, in the line segments. And we have to learn how to count them and how to add them together, So before we do that, we need to go over the formulas we learned before. Suppose you have you get given the problem like 1 plus 2 plus 3 plus 4, okay, all the way to 20, okay. Now, maybe remember how to do the problem quickly. Some students still remember like it's the sum of the first term and the last term divided by 2 and multiply by the number of the terms, okay. That's how I did it, right? The question is why this is true, right? So you should know how to derive this formula if possible. Okay. So this is you can say it has 21, right? And actually 20 is divided by 2 is 10. So it's 210. Okay. So the reason it's 1 plus 20 divided by 2 here is because if you want to find the sum of those 20 terms, what you do is you double it. Okay. You make a U-turn here, and all the way to here's 19, and here's 20. So you add them together on the vertical line, see? So every time you get the same number, it's the same sum. Of course, it's 20 plus 1. This is where it's 21 plus, 1 plus 20 from. Okay, this is 1 plus 20. It's they're all the same term, 20 plus 1. Now, of course, here's 19 plus 2. 19 plus 2 is also 20 plus 1. So therefore, how many terms do you have here? Total 20 plus 1, that's 20 terms. But this is double the sum. So the original one is going to be half of that. That's the reason there's divided by 2. Okay. So if possible, don't just memorize the formula. We needed to know why, we have this formula, why this is true. Okay. So this is the idea. Okay. For example, yeah, that's the first question. The second question, for example, if you want to add, those numbers together, right? And this is called the Asthmatic Sequence. It's increased by 1 each time. So what we got here is a formula, add the sum of the first term and last term divided by 2. Now the question is how many terms here from 5 to 21. Okay, for 5 to 21, there are 17 terms. Okay, it's not a 16 terms, it's 17 terms. So then you multiply this out. Okay, so this time 26 is divisible by 2. So 26 divided by 2 is going to be it's going to be 13, right? Times 17. Now you can multiply this out. All right. So in general, okay, we have the formula. This is a very most useful formula when we do it. It's 1 plus 2 plus 3 all the way to n. Okay, then the sum of the first term and last term, you multiply it by the number of terms. Or sometimes we just write like n times n plus 1 divided by 2. So n, okay, this is called the formula. N can be any integer. So if n is 2021, this is the year, right? And then, okay, n is 2021 times 2022 because plus 1 and divided by 2. Okay, now this one of the term must be divisible by 2. Okay, so you can quickly express 1011. Then you do the multiplication and you find the product and you get answers. Right. All right, so now let's do some math problems. We want to count. Okay, here's we have 1, 2, 3. Okay, this is the many points here. Okay, and I put another point here. So the question is, how many line segments, okay, between two dots are there. Okay, so for example, a dot could be something like that, you know, that's one line segment. I just give you an example between two dots, okay? So the question is how do you count them? There's just many of them, maybe, right? Okay, so this is a way how to do. This is how do we calculate, and let me draw the picture again. Okay, and here's what we do, right? We'll begin with the first one. The first point, I can 1, 2, 3, 4. So it's a 4. Then the second one, right? Screw back a little bit, okay? The second one, yeah, the second one, you know, this is the first one, right? Then you work on the second one, but we don't go back, only go forward. It's a 1, 2, 3. Okay, because it's already the line segment between 1 and 2 is already counted. Okay, then the third one you go forward 1, 2. The last one is just only 1. Okay, so you get a sum of the number decreasing, the sequence of decreasing numbers, right? So it's 1 by 1. So it's actually 1 plus 2 plus 3 plus 4. Now, since this number is so small, and you can quickly get it, it's going to be just 10. Okay, but if you want to use a formula, it's going to be 4 times 4 plus 1 divided by 2. So it's also equal to 10. Okay. Okay. So if we have like a 2,000 points, 2,000 dots, or 120 dots along a line, how many line segments there? Now, in that case, you have to use about the formula. So let's assume that, okay, 1, 2, 3, 4, you know, assume that. So assume given, yeah. So how many dots there? We assume that 97 dots, just assume, okay. So there are 97. Yeah, 1, 2, 3, 4, 5, you know, 96, 97, okay. And in the middle, I cannot put all the dots there. The question is how many line segments, okay, between dots. Okay. So to solve this problem, right, you just needed to look at the first one, and then how many line segments you get starting from the first one, and you start from 2 all the way to 97. So actually, the line segments, okay, on the left side, the end point is 1. Then you do have I think 96 total. So 96. Okay. So that 96 line segments, which begins from 1. The left-hand point is 1. All right. Then if you look at the second point, second dot, then there will be 95 line segments going like that. Okay. So 95. And they keep it going. Finally, the last one will be between 96 and 97. So you get 1. Then you get this the sequence of those numbers, and have to add them together, right? So when you add them together, and that is going to be, you know, the sum of the first term and the last term, okay, divided by 2 times the number of the terms, okay? So this is a pretty large number. So it'll be 97 divided by 2 and that times 96. Okay. So let's try to let's try to solve this problem, okay? So 96 divided by 2 is 48. 48 times 97, okay? So actually there are how many of them? 4,656. Okay, so you get this many line segments, okay, between two dots. And what we need to count them, suppose you have so many stations along the railroad, right? And you want to print some tickets, design some tickets. Then it depends on, if the order doesn't matter, the ticket between two stations, the order doesn't matter. Just need to print the two names of the stations. Then you needed to print design this many different tickets, okay? Because there are 4,656 pairs of dots here, or the train station here. Okay. All right, so now, yeah, let's try a slightly different problem. So here, I'm going to have this type of picture. Okay, we want to see how many line segments are there. All right. Okay. Now, when we talk about line segments, it must be a strict line. Okay, it's not like a printed tickets. If this is a this is two subways across to each other, right? If two subways cross to each other, then that's a different story. There's a line. It's not a line segment. The path can be bent. Okay. Okay. So, yeah, yeah, if you have answers, please post it to me. Click my name as a host and then tell me. Otherwise, you're going to disturb other students. Okay. Yes. I think the line segments consists of these two lines. Okay. For the first one, from here to here. Okay, let's do it again. Yeah. Okay. One is the line segments coming from this line, right? How many of them? 1, 2, 3, right? 3 plus 2 plus 1 actually. Begin with this, right? Total 6. Right? Then for the other one, okay, that's a 1, right? 1, 2, and 3. Right? 2 plus 1 equals 3. Do you agree with that? So add them together. Right? Add them together. How many you get? So it's going to be at least 6 plus 3, which is 9, right? So that's the answer. How many line segments you can get? It's 9. Okay. Now you cannot bend. If these two lines railroad subways, then it's possible it's going like this way. You have to print the tickets from between those 2 points, but this is not a line, not a strict line. Okay. So we're talking about strict lines. Now there are many other problems you can convert to the problems of accounting line segments. Okay. For example, if you choose 1, 2, 3, 4, 5, 6, so you draw lots of lines here. Then you get many triangles. Okay, so the question is, how many triangles are there? A typical triangle, I'm going to color it. It could be something like that. Okay. All right, so this is one triangle. Okay. Now, how do you count that? Okay. So you have to convert the problem to another equivalent problem, like a counting. First of all these triangles, they share one vertex. Okay. They share one vertex. Okay. So a triangle is really completely determined by a pair of points on the bottom line. Okay. If here's 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 points here. Okay. So a triangle is one-to-one corresponds to a pair of points. Right? At the bottom. Right? If I give a points for this triangle, right? So this is a 2 and a 4. So this triangle is completely determined by second point and fourth point on the line. It's a triangle in the picture. So once you converted that problem to another problem, counting the line segments or pairs of points on the line, then you solve the problem, right? So you get, so the numbers of triangles is going to be the number of pairs of points. Okay. So how do you count the number of pairs of points? One pair of points give you one line segment, right? Then that's what you count, right? So you get like a 1, 2, 3, 4, 5, 6, 7. So 1, 2, 1, 3, 1, 4, 1, 5, there are 7 pairs of points. Begin with a 1. Okay, so that's a 7. Then you look at point number 2, then you get 6 pairs of points. Then you look at number 5 and number 3, then you get 5 pairs of points and keep it going. So you get the last one is 1. Okay, so when you add them together, you will get 7 times, okay, 7 plus 1 divided by 2, 7 times, okay, 8 divided by 2 is 4, and that's 28. 28, not 14. Right? 28. Right? Because the 8 divided by 2 is 4. So there are 4, there are 28 triangles. Clear? Because you just need to count the number of pairs of points along the line. Okay? Yes. All right, so take a look at next problem. Okay. So if you have many points, too many points, 1, 2, 3, 4, 5, 6, 7, 8, like 1, 2, 3, 4, 5, 6, 7, 8, keep it going, right? And here is going to be, 67, then 68, right? So question is, how many triangles you're going to get, okay? Okay. Can you repeat what we did? Yeah, question is how many? How many triangles are there? Okay. A triangle could be, we already said that triangle is uniquely determined by a pair of points. If you choose this pair of points, then you get this triangle, right? All right. Anyone has answers to this problem? All right, so we do get a couple of different answers, and let's see which one is correct. Okay, so so the number of the triangles is going to be, right? As I said, that is going to be the number of the, right? The number of triangles is going to be the number of pair of the points. Okay, at the bottom line, on the bottom line, right? And the question is how do you count the number of points? You just count like a 1, 2, 3, right? The first one is the leading, right? So you begin with the 1, right? And 1, 2, 1, 3, 1, 4, those are the pairs of points you're going to, you're going to get, right? So total will be 27 at the very beginning. Okay, there are 27 pairs of points begin so that the first point is 1. Okay, then just decrease the number. Okay, and then add them together, the sum of the first one and last one multiplied by the number of the terms. Okay, multiply the number of terms. Then you have to do the multiplication. Okay, you have to do the multiplication. So 68 divided by 2, 34, and times 67. Okay, so it'll be 2,000. Okay, 278. I think someone got it. Okay. So that is the answer. Okay. Now, let's try a different one. So I have 1, 2, yeah. And I draw another line here. Okay. So I want to know how many triangles you can see. Okay. All right. So to count the triangles, okay, there are 2 types of triangles you can count. Okay, the triangles coming from the small one, right? And the triangles come from the larger one. Okay, right? So the triangle comes from the small one. That's no other type of triangle you can get. So the small one, you're going to have a 6 here because 1, 2, 3, 3 plus 2 plus 1. So it's going to be 6. And the same reason, okay? So you have 3 pairs of points, and 2 pairs of points, and 1 pair of 3 plus 2 plus 1. So it's 6. Total, the answer is going to be 12. Okay, 6 plus 6 is going to be 12. So there are 12 triangles here. some triangles, yeah, that's only, if there's a triangle, you either, based, yeah. So the only way you can get triangle is either like this triangle or something like that, this type of triangle, okay? Just classify them in the two categories and you count them each of, okay, in each category, in each group, right? Now let's do slightly different problem. So I have a 1, 2, 3 points. Okay, this time I draw 2 lines here. Okay. So my still have this question is how many triangles you can see? Okay. So you have to divide the triangles in 3 categories, right? 1, 2, that's the 3 lines. The triangle is completely determined by a pair of the points on one of the lines, either line 1, line 2, or line 3. That's my hint. Right? All right. So what do you got? Several students got 30. Some students got 12. Clearly more than 12. Well, what's the problem? There's a lot of problems here with 12, right? So the triangle, you see, basically determined by the pair of points on the first line, right? 1, 2, 3, right? And that's the line 1. It's line 2, the same. Right? 1, 2, 3 here, right? Just multiply them. So each pair of the points on one line determine a triangle. Okay, if this is 2 points, you can use a second line to get a triangle, right? So all we needed to do is just count how many pairs of points on this first line. So 1, 2, 3, 4. So 4 plus 3 plus 2 plus 1, which is going to be 10. And you have 3 tens here. So 10 plus 10 plus 10 is going to be 30. So there are 30 triangles. Okay, 30 triangles. Okay. All right. Now let's look at the rectangles. Okay, let's look at the rectangles. So we have there's 3 dots on each line. Okay. So now, yeah, here's still the question. How many rectangles are there? Okay. How many rectangles there? Play, no, there are more than 3 and more than 4 here. Okay. Yeah, a rectangle, you see, again, is uniquely determined by, come on, I got so many different answers, surprised. Okay, a rectangle, okay, is determined by a pair of points again. Okay, you have how many points here? 1, 2, 3, 4, 5. Yeah, there are 5 points. A rectangle, each rectangle is uniquely determined by a pair of points. So if you have these 2 points, 2 and 4, then if you're given these 2 points, then you get a rectangle, right? So how many pairs of points? So this is equal to the number of the pairs of points here on the horizontal line. Okay, to count the numbers of pairs of points, you do like that. 1, 2, 3, 4. So it's 4. Then you begin with a 2 and a 3, 4, 5, right? Then it begins with 3. Then you get a 1, 2, 4 and 5. Then the last one is just 1. Okay, so add them together. That's going to be 10. So there are 10 pairs of points here. There are 10 pairs of points. So you have a 10 rectangles. Okay. All right. Now, when we count, right? So let's talk about the product rule here. If you have a 2 numbers, okay? So you have let's see. You have a 2 numbers, A and B, okay? Let's consider pair of numbers, okay? So if A equals 1, 2, 3, 4, 5, and 6, B equals 1, 2, 3, 4. How many pairs you're going to get? Okay. So you're going to get, right? So the way we do it is you list, if you list all of them, okay? A is 1, right? When A equals 1, then B can be 1, 2, 3, 4. Okay. Then when A equals 2, 1, 2, 2, 1, 2, 2, 2, 3, and 2, 4. Right? And keep going, right? So last one will be 6, 6, 1, 6, 2, 6, 3, and 6, 6, 4. And this is called so-called matrix in mathematics. Now, to count the total number of the pairs of total number of the pairs of numbers, right? All to do is just depends on how many rows, how many columns. There are 6 rows, the 4 columns. So clearly, they are 6 times 4. 4 columns, 6 rows, right? 24. There are 24 there. Right? There are 24 there. So if you have the first number, you have a 6 choices, second number, 4 choices, then the combination, okay? Yet you're going to have 6 times 4, this many different combinations. Okay? All right. Okay. So if A has 6 choices, B has 4 choices, then how many choices for the A and B as a pair? That'd be 6 times 4 different many choices. All right? Clear? So you let the B, A changes, B changes, right? And this is get different Yeah, then just use a product rule and multiply them out. That's total 24. Now, the reason I want to do that is because I have the following question. Okay. All right, so let's begin with a simple one. Question is, how many rectangles are there? Okay. So now I have two different answers now. Clearly it's not 8 because the triangle can, as a rectangle can be this size. This is also rectangle, right? Formed by 6 smaller rectangles. Okay. Yeah, you can solve this problem separately. Okay, and because it's a small rectangle here, right? So the question is how many of this type of rectangles, you know, the smallest size. Okay. Yeah, we just count this, right? Or this type. Or this type, you know, right? This kind of rectangles. Okay. Then you have to double it because you have this row and that row, right? 2 rows. So how many points do you have here? Right? 1, 2, 3, 4, 5. So you are total get, you know, this depends on the pair of the points. Okay. So you're going to get 4 plus 3 plus 2 plus 1, that's going to be 10. Okay. Now, this is not a final answer, okay? A little more than what the Claire got. It's a 10. So for the rectangle, determined by these 2 horizontal lines, that'll be 10. Determined by these 2 horizontal lines, also 10. So, but then they also have the rectangle, the bigger one, okay? So then the answer will be 10 plus 10 and plus 10. Okay, now this 10 is about rectangle like this type. Okay, this 10 is on the top and this 10 at the bottom. Okay, it's the lower part. So those are the yeah, I can change the color, you know. Yeah, this is, I'm talking about this type of, okay, this type of. Then I change the color. Okay, I'm talking about this type. Okay, that, okay. Then the yellow one, right? Clear? Okay. So so you first of all, you count the rectangles above the middle line on the top, and you're going to get a 10. The reason you get 10 is there are 10 pairs of points on the horizontal line. Okay. Then you count the rectangles in the lower part. They also will be 10 because there are 10 pairs of points on the horizontal line. Okay. Then you consider the rectangles, occupy the top and the bottom, the lower part. So it's a 10. So the answer will be 30. Okay. Now let's try a slight different way to do. Okay, let's try a slight different way to analyze that, and that method is better to solve the problems. Okay, so a rectangle is uniquely determined by a pair of horizontal lines okay, and also a pair of vertical lines. Okay, so a pair of horizontal line could be like this. Right, this line and that line, and the pair of vertical lines. Yeah. So in this case, this is a rectangle, right? Is a pair of vertical lines, a pair of horizontal lines. So the question is how many choice for the vertical line, a pair of horizontal lines. The number of the pair of horizontal lines will be 1, right? I think 3. 3 here. Okay. A pair of vertical lines depends on the number of the points on the vertical line, right? 1, 2, 3, 4, 5. So that's gonna be 10. So the answer is 30. Do we get the same answer? Yes, but different approach. Okay. So you have to use the product rule here. If it's because a rectangle is uniquely determined by a pair of horizontal lines and pair of vertical lines. So you just need to count how many pairs of horizontal lines, how many pairs of vertical lines. Okay, and the product of those two numbers give you a rectangle, the number of rectangles in different locations for different size. Okay. So let's see. So now we're going to look at slightly different problems. Okay. I'm going to make it a little bit more complicated. 1, 2, 3, 4, 5, 6. Okay. Okay. How many rectangles are there? So a rectangle, right? Remember, is uniquely determined by a pair of horizontal lines and pair of vertical lines. Okay, a rectangle, so 1-to-1 corresponds a pair of horizontal lines, a pair of vertical lines, right? The question is how many pairs of horizontal line, how many pairs of vertical lines? Then you have to calculate. So this is determined by one pair of horizontal lines, one pair of vertical lines. So the number of pair of horizontal lines Okay, let's see how many of them. Just horizontal lines, right? So depends on the number of points. Already did that, right? 1, 2, 3, then a 1, 2, and a 1. So it's 3 plus 2 plus 1, 6. Okay. So the number of pairs of vertical lines. Okay, let's see how many points here. 1, 2, 3, 4, 5. Right? Then 1, 2, 3, 4, right? Something like that. So 5 plus 4 plus 2, plus 3 plus 2 plus 1. Right? Okay, so let's see what do we got here. I think it's 15. All right, so 15. Now you have 6 pairs of horizontal lines, so you can keep changing them, right? And also have 15 pairs of vertical lines, you can keep changing. Any combination, all right, gives you a rectangle, right? So it gives you a rectangle. See, you choose this pair, then you choose, right? You choose other pair, choose those 2 pairs of horizontal. So this is a rectangle you get. Right. Okay. So the answer is the number of the combinations will be 6 times 15. Okay, 6 times 15. So how to do that, right? 6 times 15. It's 90. All right, 90 is the correct answer. So that's 90 different rectangles. Okay. All right, so now I'm going to, this is different, okay? 1, 2, 3, they're all squares here inside. So the question is how many squares? Okay, how many squares? Okay, how many squares? Well, so you count the squares in this size. It's a 1 by 1, right? You also count the squares 2 by 2. That's all you need to count. Okay. So 1 by 1 square, it's easy to count. Like, you have this size 2, the size 1, 2, 3, 4, right? 2 times 4, it's 8. So 2 by 2 squares, how do you do that? It's determined by, actually it's determined by pairs of points here. So 1, right? 2, and I think 3. That's only 3 here. Right? So 8 plus 3 is going to be 11. So there are 11 pairs of square there. Okay. So a square is completely determined by 1 pair of horizontal lines of equal distance. Because the distance is going to be, for example, 2. Then also have the same number 2 to pick up another pair of vertical lines. Okay. And it's only the pairs of, those 2 pairs of lines, if the distance between 2 lines are all equal, same, then you get a square. Okay, otherwise, it's not going to be square, it's a rectangle. All right. All right, so let's do a little bit more general. All right, I'm going to draw. Okay, here's 1, 2, 3, 4. 1, 2, 3, 4, 5, for example. Okay. So this side, the 1, 1, 2, 3, 4, 5. So it's a 5. 1, 2, 3, 4, 5, 6. 6. This is called the 5, 6. Yeah, picture. Okay. So the question is, how many squares there? Okay. A typical example, a square is going to be like this type. It's 2 by 2 square. So you should count how many 1 by 1 squares, 2 by 2 squares, 3 by 3 squares. Right? Then add them together. All right, so that's 1 by 1 square. Let me do a couple of them for you. Okay, 1 by 1 square, it's easy. Just 5 times 6, 30. That's 30 square. Okay. You have a total 30 1 by 1 square there. How about how to count the 2 by 2 squares? 2 by 2 squares, a 2 squares completely determined by pairs of horizontal lines with distance equal to. Okay. The question is how many pairs? You just move this down a little bit. 2, 3, 4. Okay. And then here you also have to use the pair of vertical lines, but with the same distance too. So you have 1, 2, 3, 4, 5 pairs. Right? 5 pairs. You can only consider vertical lines with a distance equal to. So that is B5. So 20. So actually that's 22 by 2 square there. Okay, you have to do the product because 4 choices vertically, 5 choices horizontally, then the combination you have 4 times 5, this many choices. Okay, then the 3 by 3. 3 by 3, I think you just needed to reduce the number here and the reduced number. It's 12. Okay. Okay. And then it's 4 by 4. It's a 2 times 3. Right. Finally, will be 1, 2, 3, 4, 5 by 5. Okay. So it's 1 times 2. So that is going to be 2. Okay. So now add them together. Total will be 30 plus 20 plus 12 plus 6 plus 2. Okay, that gives you a total number. Okay. Okay, let's finish the computation. Okay, total 70. Right, 70 is the correct answer. Yeah, that's a lot, right? All right, so now I'm going to ask you to do one more problems. Okay. We go back to this. So 1, 2, 3. Okay. And this time, okay, I'm not going to connect this, just connect this too. Okay. So let's have a quick review. Okay. So questions: how many triangles are there? Okay. How many triangles there? So you first of all, you have to count the triangles determined by those 4 points. 1, 2, 3, 4, 5, right? Right. Each of these pairs of points give you the triangles. So you have a 1, 2, 3, 4, right? 4 by 3 by 2 plus 1. So this is you get this many triangles. Okay. I'm talking about a larger triangle determined by this vertex and pair of points on the line at the bottom. Okay. So it's going to be 10. Right. Then you will count the triangles with the base along on this line. Okay. So then how many points? This time it's not the 5 points, okay, only 4 points, right? So 1, 2, 3. So it'll be 3 plus 2 plus 1. So it's going to be 6. Clear? Yeah, because each of them, you give you triangles like that, each pair of the points. So I don't know how to get 20 or 10, right? That's it, right? So add them together, then it will be the total is going to be 10 plus 6. It's a 16. Okay, you don't get a 20. The reason is the line in the middle across this triangle. It's does not, just only cover the four lines from the vertex on the top at the top. So that's why just 6, not multiple by 2. Okay, so just you have to be careful. Look at the problems. Don't just simply multiply by 2. Okay. Okay, there's now we just need to count how many pair of points if you get certain number of points, right? So the general formula is, this is going to be right. If you have a bunch of points, let me summarize that. Okay. The number of points, the number of pair of points, okay, selected from a group of endpoints, okay, is going to be, let's trying to get a formula, right? So you have endpoints. It's 1, 2, 3. When you do a math problem, right? You need if you repeatedly do the similar problems, you need to think about, can I summarize? Can I get the general theory? Something like that. Then you become a mathematician, right? So that's very important. Don't just give me the problem, you finish that without thinking. Maybe you still memorize the method, but does this method can be, can this method can be generalized, can be used to the general case, and you're trying to find the thing by yourself. So you assume, instead of assuming 4 points, 5 points, I just assume n points. Then you look at this, right? So how many pairs? The first one, if you fix the point 1, you get n minus 1 pairs. If you fix the point 2, you get n minus 2 pairs. This kind of thing. Something maybe you are able to do this. And add together, the largest number here is n minus 1. So it's going to be, it's going to be sum of those two numbers. So it's n minus 1, the sum of two numbers, right? So actually it's going to be n divided by 2. Okay, think about that's how do you get the formula. So next time you use your own formula to quickly answer the question. Okay, so the number of the pair of the points, if we select it from the group of n points, and just n equals, for example, 2000, then be 2000 minus 1 times 2000 divided by 2. Okay, so let's stop here. And next topic probably is about different. It's about rates.